What's up, y'all? This is Tom, and this is Like a Math Class. In this video, we're going to talk about parallel and perpendicular lines. We're going to be looking at what determines something to be parallel, and we're going to look at what makes something perpendicular. Let's get to it. So here we've got the definition of parallel lines. It says two or more lines on the same plane that never meet or intersect. Now typically we're considering these things to be maybe something like this, where we've got two lines. Maybe they look like this, maybe they don't, but they're two lines on the same plane. This is called the Cartesian plane right here. Now, when we say the same plane, we're typically meaning on a flat surface. Now, typically we say the same plane because we're talking about a flat space, but we could also have two lines in a three-dimensional space that look something like this, where this one is going this way, this one's going this way, and they're never going to meet because they've got this distance between them. For our purposes, what we're going to be talking about is we're going to be talking about on a flat space, on the Cartesian plane. So if we're talking about parallel lines, what that means is these two things are never going to meet. They're never going to cross. And one way for us to identify that is to find the slope of these two things. And remember, the slope is quite simply the change in y over the change in x. And these are the symbols for change, right? This delta. We talked about that in our slope video. The change in y and change in x, or we just quite simply just write the change in y over the change in x. And that's what we're looking for to find the slope of these things. And when I say the change in y, I really mean the change in the y value and the change in the x value. So let's be just a little bit more specific there. So if I want to find the change in the x value, or in the purple line, I can start at one point and I can go to another point. Those two look like they're crossing right at intersections. So here I'm going up one in the positive direction, and here I'm going to the right two in the positive direction. So there's our slope for our purple line. Our slope for the purple line is going to be the change in y, 1 over the change in x, which is right here, which is positive 2. So what about the green line? Well, maybe the green line where maybe we look like right here, and where's another point? Here's another point. So in the green line, I could maybe come down this way. I'm going to go down 2 points, which means a negative 2. And here I'm going to go to the left 1, 2, 3, 4 points. So I'm going to the left 4 points. So in my green line, our slope is going down 2. So if I'm going down 2, I'm going to go negative 2. And I'm going to go to the left 4, which means I'm going to the negative 4, or the negative direction for my x. And those things are also going to simplify to 1/2. So if I have the same slope for both of these things, then they're never going to meet. Because when one goes up, the other one goes up, and when one goes over, the other one goes over the same rate. So it's always happening to be, they're always going to stay parallel. They're never going to meet. Now, of course, if we take this one and if it were to pitch like this, maybe here it's not going to meet, but we're going to see that this thing is at some point going to meet as we extend this on further and further. So maybe that one goes up there. And now this purple one, yeah, so that one will at some point meet out that way. But, typically all we do is we look to see, are the slopes the same? And if the slopes are the same, then we're good. So really what's going to happen is you're probably going to be given 2 points or some points on both the purple and the green line, and you're just trying to see, are they the same slope or are they not? So really all you're going to do is find the slope of one and find the slope of another. Are they the same or not? Yes, they're the same slope, so the lines are parallel. It's as easy as that. So let's take a look at perpendicular lines. So here we've got the definition of the perpendicular line. We've got two lines that meet and form a right angle at their point of intersection. And we can see here I've got a nice vertical line here, a nice horizontal line. You can clearly see that this is making a right angle. And just as a side note, sometimes when we're talking about perpendicular lines, we use the symbol like this. and that just indicates, oh yeah, we've got kind of a right angle right here. So it's easy to see when lines are perpendicular when you're looking at them and they're going nicely across your grid. But what happens when this thing doesn't go so nicely? Maybe it's tilted like this. So I haven't changed the angle. I don't know if you noticed that, but I haven't changed the angle at all. All right, so here we're going to call this L1, and here we'll call this L2. So now we need to find the slope of each of these two things. So we're going to start by finding the slope of L1. So let's find two spots that we can count to. It looks like there and there. So we go up 1, 2, 3, 4, 5, 6. So we're going 6, up 6. So 6 in the positive, and 1, 2, 3, 4, 5. And we're going 5 in the positive for our x. So we've got 6 over 5 for our slope there. Now, what about our other line? We've got this spot here and this spot here. So we're going to go up 1, 2, 3, 4, 5. So that's going to be 5 in the positive direction for our y. So our slope of L2 is equal to 5 in the positive for our y, and then we're going to go back 1, 2, 3, 4, 5, 6. So we're going to go backwards 6, so we're going to go in 6 in the negative direction. So what we have here, if you look at these two results, we have what's called the opposite reciprocal. Opposite means the change in signs. So we're going from a positive to a negative, or we're going to go from a negative to a positive. Negative to a positive in our signs of the slope. And reciprocal just means that we flip the numerator and denominator. Notice here we flip the numerator and denominator for these two lines. So there's our reciprocal, and the opposite, this is a negative slope, this is a positive slope. So if you have opposite reciprocals for your slopes of two lines, then you know that they're perpendicular. Also, the product of perpendicular lines, this is the symbol that this is the symbol that we use for perpendicular lines. The product of perpendicular lines is equal to -1. So that's another check that you can do to see if these two things are perpendicular. So if we take 6/5 from line 1 and we multiply that by a -5/6 from line 2, then we can see here that we end up with -30 over 30, which gives us a value of -1. So these two things are indeed perpendicular. So that's what we have to say about parallel and perpendicular lines. Parallel, they're lining up, never touching. Perpendicular, they're always meeting at a right angle no matter which way it's tilted. I hope that helps. I'll talk to you in the next video.